Okay, for this lesson we are going to be talking about applying congruence and triangles. First things first here, we can go over and look here. What we're talking about with the congruence here is we're trying to make sure that we have the same angles and the same sides. So the angles must be congruent, the sides must be congruent. So you can see, like with our congruent shapes here, so these are turned differently, they're facing in different directions. However, we can generally assume here, with what they've given us, that the shapes are actually the same. On the other side over here, the not congruent shapes, like the first triangle here and the second triangle, they appear to have the same angle measure, but the sides are bigger on the second triangle here. And then with the second and third triangles, they're about the same size. However, our sides are completely different there. So for two geometric figures to be congruent, they have to have the exact same size and shape, the same sides, and the same angles. So whenever you're writing out a congruent statement for your triangles, what you want to do is make sure that your angles are all lined up here. So you can see, looking down here, we have these two triangles. We have our three sets of sides, so 1, 2, 3, and 1, 2, 3, that are congruent. Then we also have our three angles. We have this angle, second angle, third angle, and we have our first angle, second angle, third angle. Okay, so we can see that those are congruent. So whenever you're writing your congruent statement, you want to keep that order between the two. So for this first one here, we could write this as A, B, C, so triangle ABC is congruent to triangle FED. Okay, you can see we're keeping the same order with the angles. Angle 1, angle 2, angle 3, angle 1, angle 2, angle 3. We could write that a totally different way. We could write it as BCA is congruent to EDF. Okay, so it works either way. It doesn't matter which order you do it, and you could also do it starting with C or going in a different direction or whatever. So it doesn't matter. You just need to make sure that you have your parts lined up between the two. Okay, so we're writing a congruent statement for the two triangles here for example 1. So you can see with the way that these two triangles are laid out here, they don't have all of their parts lined up, but we can see what parts correspond to what parts on the two different triangles. One thing that you might want to try doing, this is over on the left side of the frame over here, one thing you might want to do if you're having a hard time seeing how it's set up is to redraw your triangles so you have the parts set up in the same order. Like we basically just moved our JKL triangle over here, but we rewrote our triangle here starting with TSR over here. So that might help you, especially on some of the more complicated ones. I would recommend getting in and redrawing it. But we can see again with the angles, if we're starting with JKL, so we're going with angle 3, 1, 3, 1, 2, and we're going 3, 1, 2 here, so that's angle TSR. So triangle JKL is congruent to triangle TSR. For completion here, so the corresponding angles, J corresponds to T, angle K corresponds to angle S, angle L corresponds to angle R. The corresponding sides, JK corresponds to TS, segment KL corresponds to SR, and segment LJ corresponds to RT. Okay, so we have example 2 here. So it gives us, in the diagram, DEFG is congruent to SPQR. So DEFG is congruent to SPQR. So again, so you can see they're not lined up here, but we can see pretty clearly what parts are corresponding to each other. And even if we couldn't, we can look right back, and this tells us that D corresponds to S, corresponds to P, F corresponds to Q, and G corresponds to R. So what we're doing is we are finding the value of X and then the value of Y. So for the first one here, we have that FG is congruent to QR. So then we can go back in. We have our 12 is going to be equal to 2x minus 4. So we can go ahead and work that out here. Then we have 16 equals 2x, and our x is equal to 8. Okay, and then on part B, finding the value of y, we know that angle F is congruent to angle Q. So angle F congruent to angle Q. We just found out what x was. That was 8. So we can go plug that back in here. So our 68 equals 6y plus x. Found out x was 8, so we put that back in. Subtract our 8, that'll give us 60, divide by 6, and that will give us our 10. So y is equal to 10. Okay, so here's example 3. So the question says, if you divide the wall into orange and blue sections along line segment JK, so JK right here, will the sections of the wall be the same size and shape? Explain. Okay, so we have most of the information that we need here. We have angle 1, or I'm sorry, side 1, side 1. We have our side 2 congruent to side 2. We have our side 3 to side 3. So we can then see our fourth side here, which was the JK. So we know by reflexive property that that's going to be side 4 congruent to side 4. That makes pretty obvious sense there. And then with our angles, we have our two right angles over here, our AD and our BC, that are congruent. And then we can show that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. And we can do that by the alternate interior angles theorem. So that's our way of showing that we have our 4 angles are congruent. We already showed our 4 sides are congruent. So yes, the 2 sections will be the same size and shape. Okay, so next we're talking about theorem 4.3 here, which is the third angles theorem. And this is yet another one of those common sense theorems here. So the third angle theorem just basically says if 2 angles of one triangle are congruent. Okay, so, oops, wrong button there. Okay, so our 2 angles are congruent on the 2 triangles. Then the third angles, so our angle C and angle F in this case, are also congruent. I don't think I need to explain that any further. Okay, so that should make perfect sense. So we can go down here to example 4 using the third angles theorem, and we're trying to find the measure of angle BDC. So BDC. And you can see we have this angle here is 45. It also has our one little line there, and this has our one little line over here. Okay, so let me switch to my pen tool. So we can also say that that's 45. We have the 30 degrees down here for angle D with the two lines. And we have the 30 degrees also down here for angle C. And we were trying to find angle BDC. So let me switch back here. Okay, so BDC, which is right here. So we found our 45-degree angle, we found our 30-degree angle. We know our three angles are going to add up to 180 degrees. So we can go back in our 180 minus 45 minus 30, and that's going to give us 105 degrees. So measure of angle ACD and, for that matter, BDC are 105 degrees by the definition of congruent angles. Okay, so last thing here, we have a few properties of congruent triangles, and these all correspond to the properties that we had previously with segments and angles. So the first one here, so for Theorem 4.4, our properties of congruent triangles, our first one, the reflexive property of congruent triangles, so that's just saying for any triangle ABC, ABC is congruent to ABC. Okay, so hopefully you guys know the reflexive property by now, so ABC is congruent to ABC. Then we have the symmetric property of congruent triangles, and we've had the symmetric property a couple times already. Okay, so that's saying if ABC is congruent to DEF, then DEF is congruent to ABC. Okay, so like I say, you should know the symmetric property by now. And then our transitive property of congruent triangles, so that says our ABC is congruent to DEF, and DEF is congruent to JKL. Then, of course, we know that ABC is congruent to JKL.